create a similar example to the one that we had in the last video so that we can explore this idea of object references that we just learned about in the previous lecture, but now by writing some code. So let's start this lecture simply by just writing an object. I'm going to call this object Jessica because it will contain some information about this person, so this Jessica. So the first name is indeed Jessica, then the last name is Williams, and I believe we have used actually this person before, and let's say the age is 27. Now, as we already know, this object will now be stored in the heap inside the JavaScript engine of our browser right here. So in this case, this browser, then I'm running this code in. And then the call stack will hold a reference to the memory address at which the object is stored in the heap. All right, and so let's now again see in action what we just saw in the slides in the previous lecture. And so what I want to do now is to copy this object here into another object. So let's pretend that this Jessica did marry and changed her last name to something else. So let's say married Jessica should be equal to Jessica. As we already know, this is not really going to work, but again, we want to actually see that problem that we just talked about here in practice. So let's say married Jessica dot last name should now change to Davis. And so then let's log to the console the result of these two things. So before, and then just Jessica, and I'm not sure if we ever did this, so logging two things to the console, but this is a nice trick that I like to use, which is first to log a string, basically as a label of what I'm logging then here second. So this function, this console.log function, accepts also multiple arguments, and then all of them will be logged to the console. So here, then after, should be married Jessica. And now, before saving this code and reloading the browser, try to guess what the output will be. So, did you do that? Well, then let's save, and let's see. And so here the after object, indeed we get the last name as Davis, as we just changed it here. But then the strange thing, again, is that the last name also changed to Davis in the original object. So this one here before, so this original Jessica object, right? So this is extremely strange, right? Well, not for you anymore, because you already learned in the previous lecture why exactly this is happening. So this is happening because when we tried to copy the original Jessica object, so right here, it did actually not create a new object in the heap. Instead, this married Jessica is simply the exact same reference as Jessica. And so now married Jessica and Jessica are two variables that point to the exact same object in the heap. And so, of course, it makes total sense that if we change a property here on married Jessica, then that change will also get reflected in the variable Jessica. So this one right here. Again, because they are essentially just two different names for the same thing. Now, by the way, this is actually also the reason why we can change properties on the married Jessica object, which was declared using a const, and also on the Jessica object itself. So again, these two were actually declared using const, which we learned earlier are for constants. So we learned back then that we cannot change the value of a constant, right? But we can still change the property values like we just did here, right? And so again, that's because we're not actually changing the memory address, so the reference to the object that is stored here in the constant. What we could not do would to actually assign it a brand new object. So we could not do actually this. So we could not do Jessica should be equal some new object with x23. So here we would get an error, assignment to constant variable. But we can do something like this. H should be equal 30. So here it's not a problem because we're not changing the reference that is stored inside this Jessica constant. All right? So again, just to make this completely clear, what we did here is not okay because this here is a brand new object. And so it will get a new reference in the heap. And so then here we are attempting to assign that brand new reference to this variable here, which is a constant. And so here we're really trying to change the value itself this time. And so this is not allowed in a constant. It would be allowed if this was a let. So then here we wouldn't get any problem. But again, if it is a const, we cannot do this. So this is a fundamental, very important difference, and so please make sure that you really understand this part. Now let's just make this here slightly more interesting by actually transforming this here into a function. So just so you see that the same thing will also happen when we pass an object to a function. So let's say marry person, and so this will then receive the person object and a new last name. So we're basically going to create a reusable way of doing what we had here. So here, then the person that it will receive, and let's actually call this function first, which many times makes it easier to see how to actually do this. So again, we basically want to replace these two lines here, and so let's say that we want the married Jessica to be equal of calling this function, and then with the original person, which is Jessica, and then with the new last name, which remember was David, or Davis. So here let's call it actually original person, just to make this a bit more clear, and then here we just do what we did earlier here. So we just say original person dot last name should be equal the new last name, and then we just return the original person. So basically we just changed the last name here, and so now here we get again the last name Davis after the marriage, but also in the original Jessica object, which is this one right here. So what this means, again, is that we have the same situation as before, even though this time we didn't manually copy the object like we did here. But what we did do was to pass the object into the function here. And so this original person then becomes this object here, but it will, just like before, be the exact same object in the heap. So only the reference is copied or passed into the function. And then as we change this original person object, what we're actually changing is this Jessica object that we passed into the function. And so then we get the last name Davis in the original and in the married Jessica. All right, so very important to understand that here, in this situation, as we call the function, basically the same thing happens as right here. And since this situation here is way more common, it's important to keep that in mind. So objects are not really copied when we pass them into a function, but instead we only pass the reference. And so it is still the same object in the heap inside the function as it is outside the function, like here. All right, but now what if we actually wanted to really copy the object itself so that we could then change one without changing the other? Or in other words, let's say that we now want to create a brand new object in the heap, but which looks exactly like the original object. So again, that's actually what we wanted to do here, but couldn't really do, because this is not how we create a true copy of an object. So for this, let's actually create a new object. So I will just copy that one, and then we will add another property here, which is going to be the family. And here let's specify an array. And let's say that Alice and Bob are the family of Jessica. Let's call this here Jessica2. And so this is the object that we now want to really copy. So creating, again, a brand new array, or a brand new object actually in the heap, but which contains basically the exact same properties. So let's say Jessica copy. And then here the way we do this is by using something called the spread operator. And more about what the spread operator actually is. But the way we use it is to create, as we just said before, a brand new object. And then we can use these 3 dots. And then here, Jessica2. And actually, let's change the names here. So I want to call this one here Jessica1. Let's then change that here and here and here. And then this one here just Jessica. So to keep our code a bit more readable in here. Okay, so again, here this is the spread operator, which basically places all the properties of this Jessica object here into a brand new object, which is what we're specifying here with these new curly braces. So these are creating a brand new object, and then all the properties of Jessica are placed in there. And so then, really, a new object is created in the heap, and the reference to that object will be stored here in Jessica copy. And so now, if we do Jessica copy dot last name and set it again to Davis, so let's again log to the console, and now let's just log both of them at the same time here. So Jessica and Jessica copy. Well, then here we get an unexpected result. But that's because here I created .new last name. So that was a mistake. Maybe you saw that. So here it should, of course, be last name. So just like here. So we're changing the last name to Davis. And so yeah, here we actually get the result that we were looking for. So the original keeps the Williams as the last name, and then the new one, so the copy, has Davis as the last name. So as we changed it here. And so with this, we kept the original object completely intact. Because in fact, we now only mutated the last name. So we updated or changed this last name on the copy, which is a brand new object in the heap. However, this is still not perfect. So there's still a problem. So let's experiment with something here so that I can show you what I mean. So let's say Jessica copy, and then dot family, which remember is this array right here. And then let's place a few more names in here, because basically when Jessica marries, she gets some more new members into her family. So let's also add Mary, and also another one. So let's say John here. All right, then let's log it to the console. Let's maybe get rid of this earlier one here. And I'm just going to grab this one. So here it's now Jessica and Jessica copy. So remember how we pushed these 2 elements here into the family array of Jessica copy. So only this Jessica copy should be affected, right? Well, let's see if that is actually the case. So give ourselves a bit more space. Open up these 2. And now notice how both the after, so after the marriage, and the before, both have Mary and John added to the family. Well, that's very strange, right? Didn't we just create a brand new object in here? Well, yes, we did. But remember how I said that what this does is basically to copy all the properties of this Jessica object into the new object. But notice that this family here is actually an object, because remember how arrays are just objects. And so this is essentially just like a variable inside the Jessica object, which means that this object here is again in the heap, and this here just holds a reference to this other object. So this is what's happening here. We have an object, and so then in that object we have a primitive, another primitive, and another primitive. So here everything is straightforward, but then here we have another object, so basically a nested object. And so this will get a brand new object in the heap, and this family property will point, so it will create an object reference to this object. And so what we did here when we copied the properties of the Jessica object was to also copy the reference to this array, so to this object right here, which means that both Jessica and Jessica copy have the family property, which both point to the same object in the heap. So essentially what we did here, so this copy that we made here only copied the first level of the object, but not the nested object. So since we only copied the first level of the object, so basically these primitives right here, which were really copied, then this is what we call a shallow copy. So again, only the first level. And shallow copy is a term that you will hear a lot in JavaScript. So again, this other nested object here hasn't really been copied. So Jessica or actually Jessica copy and Jessica, they're both having their family property pointing to the exact same array. And so therefore, as we push these 2 elements into the array using the Jessica copy variable, the same thing will appear in the original Jessica object. So let's write that here so that we have a shallow copy, which didn't really solve the problem that we wanted to solve in the first place, right? We wanted really a complete copy of this entire thing, not just the first level. And so, in other words, what we wanted is a deep copy, which is also called a deep clone. And so this then copies the entire object, including all the nested objects. And in the real world, oftentimes this is exactly what we want. So oftentimes we need to deeply clone an object, for example, when we want to manipulate some big object in our code while ensuring that the original data always stays the same. So let's do that here. So now let's do the deep copy, or a deep clone, as we could also call it. So let's call this one here the Jessica clone. So it could be called a copy or a clone. You will hear both of these terms. And so for that, we now have the new structured clone function that is now available in all modern browsers. So again, this is actually pretty new. In some older browsers, this will not work, but don't worry about that for now. So again, it is called structured clone. So actually just that suggestion that was there on the screen. And then we just pass it the object that we want to clone. So that is indeed Jessica. And so let's not try this exact same thing, but with the clone. So clone, and then also this one here, so that we don't have to type so much. Here, just to distinguish it from the other ones, let's say after the clone, or actually let's just say clone here, and maybe original. So here we get our Jessica clone, and let's see. So this is the original, this is the clone, and as you see, we still have the Mary and John here from earlier. So it's been added here and here, but this is still from this part. So let's comment out maybe all of this. And for this, I'm actually using a VS Code shortcut. I'm not sure if I mentioned this earlier. It is just Command or Control on Windows, and then the slash. So this right here. So that's a bit easier than just typing it out. And so let's see that again. And so now, beautiful, our original nested object here stays the same. So it is still only this original, but then in our clone, we actually get Mary and John added to it without it being added to the original. So that was the problem we had here earlier, but now our structured clone solved that problem. So this function here can be pretty important, and so this is one of the big takeaways of this lecture. Besides understanding how this whole thing works, also keep in mind that with this function here, you can create deep clones of objects. And this was actually a lot harder a few years ago, because back then we had to use an external library like Lodash if we wanted to create deep clones. But now we have this structured clone function, which has been added to browsers, which makes our lives a lot easier. So this is the big difference between a shallow copy and a deep copy. And always keep this in mind, because you will hear about this a lot when you work with JavaScript in the future.